All right, so normally for this unit, we'd start off with the bell ringer. So real quick reminder, if you're taking a look at these two graphs, is it a function? What do you think? Which one? If we look at the first one, is this a function? Well, it's on a graph, so you use the vertical line test. If I draw a vertical line, no matter where I draw it, I can only hit that graph one time, so that is a function. What do you think about this one? Yep, should be not a function. Wherever you draw a vertical line, hits it twice there. If I draw a line right here, hits it once, twice. So function, not a function. So we've already talked about how to determine if a relation is a function or not. So now the next thing we're going to do is I can identify whether a function on so we're going to look at tables, graphs, and equations, and we're going to tell whether or not that function is linear or nonlinear. So normally that would start off with putting this on the board, two graphs, and having the class look at it and tell me, okay, compare and contrast. What do you see? What's the same about the graphs? What's different? Normally, students would say they are both increasing. They would say that this one has a straight line, that this one's curved, and then we would use that to talk about linear or nonlinear. So first thing right now, if I was you, get out a piece of paper, label it linear or nonlinear, and then take these notes to help you. So I'd write these two definitions down. Linear, there is a constant rate of change making the graph a straight line. So the graph's going to be a straight line. It's got a constant rate of change, which means it has a constant slope. There is a slope of the line. You could say the slope is 2 or the slope is 1/2. It's going to be the same slope across the whole line, and it's going to make a straight line. If it is nonlinear, then that means it's not a constant rate of change. That means at one spot on the graph, it could have a slope of 2, but then on another spot of the graph, it might have a slope of 8, and so it might be steeper. The graph will not be a straight line. The graph could be a curved line. It could be a straight line, but it could be a straight line going up and then going sideways. So it's not a complete straight line going the same direction the whole time. So there's linear and nonlinear. And on these problems, I'm just going to give you, here's a graph, or here's an equation, or here's a table, and you've got to be able to look at it and tell whether it is linear or nonlinear. So we'll start off by looking at tables. Is the rate of change constant? Is it the same? Is the slope the same? So if we look at this table, how do we tell if the rate of change, you called it rate of change in 7th grade, and 8th grade we call it the slope. It means the same thing. So if I look at this table, I need to find the slope and see if it stays the same all the way down the table. So we look at our x values and we see what are they counting by. So our x's goes up by 2, up by 2, up by 2. So that's going up by the same thing the whole way. Then we look at our y's, down 15, down 15, down 15. So since the x changes by the same thing the whole way, the y changes by the same thing the whole way, that means that it will be linear. It will be linear because the table is changing by the same amount between every line. Whereas we look at this one, we look at our x's, up 3, up 3, up 3. So far so good, but then you got to make sure you check your y side. Goes up 15, up 33, up 51. So is this graph going up by the same amount or changing by the same amount between every line? No. So it's nonlinear. It's that simple when it comes to the tables. You just look at the table and see what's each line changing by. Is it changing by the same thing all the way through the table? If it is, great, it's linear. If it's not, nonlinear. All right, so let's take a look at that table. Look at it and you decide. Pause the video, decide whether you think it's linear or nonlinear. All right, hopefully you pause the video and you have a decision, and let's see if you were right. It is linear. The x side goes up by 5 each time. The y side goes down 4, down 4, down 4. Since it changes the same each time, It's linear. All right, if we look at this table, and this is set up a little bit differently. Instead of the X and Y being a T-chart where the points are going down, they can list it going horizontally, and it's the same thing. You just got to look at it a different way. So the X's are on top, Y's are on the bottom. If you look at that, what do you think? Pause the video, you decide, linear or non-linear. If you did that, the top, 0, 2, 4, 6, it's counted by 2. The bottom, 0, 2, 8, 18, goes up 2, up 6, up 10, so non-linear. All right, so the tables are pretty simple. That's all you're doing. You just look and see what it's counting by. All right, now switch it over to graphs. Graphs are even easier than that. All you're going to do on a graph to figure out is it linear or non-linear is look at it and determine, is the graph a straight line? So if we look at this one, here's your line. Is that a straight line? Yep, so it's linear. What about this graph? Oh, no, that one curves, so non-linear. This one, straight line, linear. So remember, I said with functions, there's a lot of topics mixed in with functions. A lot of things you're going to need to be able to know for the test. However, they're not tough topics. It's a lot of different things, but they're pretty easy topics. So straight line, linear. So now look at these three. Pause the video. You probably don't even need to. You probably look at them right now before I'm done with this sentence. I already have it done. Linear or non-linear for each one. Think about it. Look at it. Look at the first one. What do you think? Linear or non-linear? Straight line, linear. Second one, there's your line. Linear or non-linear? Straight line, linear. If you look at the third one, it curves, non-linear. Pretty simple. It's all you got to do for a graph. All right, so last one you got to know. Looking at an equation, tell if it's linear or non-linear. This one takes a little bit more thought, but you write down these notes, you'll have them, so you'll be able to look at the equation, look at your notes, be able to determine just by looking at it whether it's linear or not. So first thing to remember, if you have x to the first power, then all you're going to see is just x if it's in the equation. And if you have x to the second, or x to the power of 0, then that just equals 1, so then there won't be an x. So that's something to remember when it comes to this right here. Write down what's inside this box. Your equation is linear if the x is raised to a power of 1 or 0. So if you have an x and the exponent is 1 or 0, then it will make a straight line. It will be linear. And the x cannot be in the bottom of a fraction. So that if you look at the equation, the x cannot be in the denominator. All right. It's also linear if the x or y is missing. So if there's not an x in the equation, it's linear. If there's no y in the equation, it's linear. So those are the things you need to look for. Find the x and see, okay, what's the exponent on the x? Is it a 0 or a 1? If it is, great, linear. If it's the exponent on the x is a 2 or a 7 or a -3, then it's not linear. Next thing, the x cannot be in the bottom of a fraction. If it's in the bottom of a fraction, you know it's nonlinear. And then also, if the x or y is missing, then it's linear. All right, so if you write that down, you got those things to check, should be really easy. So we look at this first one. First thing you look at is find the x. All right, it's right there. What is the exponent on the x? There's nothing there, so that means it's a what? It's a 1. So if it's a 1 or a 0, then it's linear. You're good. That's all you got to do. All right, if you look at the next one, look at the x. The exponent on the x is nothing there, so that means it's a 1. So normally you would say, oh, it's a 1 linear, but where's the x? It's in the bottom of a fraction. You have 6 over x. So if the x is in the bottom of a fraction, automatically nonlinear. Nonlinear. The x cannot be in the bottom of a fraction. If it is, then you're going to have a curve in your graph. The graph will not make a straight line. All right, y equals 1/2 times x. So you've got x, it's not in the bottom of a fraction. What's the exponent on the x? There's nothing there, which means it's a 1. So if it's a 1, then that means it is linear. All right, we look at this equation. There's our x. Find the exponent. What is it? It's a 3. Well, it has to be a 0 or a 1. So since it's a 3, it's nonlinear. And then y equals 4. Well, remember, if the x or the y is missing, then it's linear. So I look at this equation. Oh, there's no x, which means it's linear. It's all you're going to do on the equation ones. Find the x and then see what the exponent is. Make sure it's not in the bottom of a fraction. And then also check and see, is the x or y missing? So if we take a look, y equals 3x over 2 plus 1. What do you think on that one? Find the x. There's no number there, which means it's a 1. It's on top of the fraction, which is fine, so it's linear. So that one would be linear. If we look at this one, find the x. What's the exponent? It's a 1, so you're good. Linear. All right, look at this one. Find the exponent. It's a 2. Can we have a 2 for the exponent? Nope, nonlinear. This would become a big curved graph. We can't have that. So nonlinear. I already said this one was linear. Popped up out of order. I need to fix that. All right, if we look at the last one, y equals 2 over x plus 5. The exponent on the x is a 1, which is fine, but the x is in the bottom of a fraction, which makes it nonlinear. All right, if you have questions on these, let me know. Come to the Google Meets, email me, and we'll work through some examples together. All right, pointers to keep in mind. If a graph is linear, or a graph is linear if it is a straight line. So you got to make sure you know that. A table is linear if the rate of change is constant. And an equation is linear if the power of x is either a 1 or 0 and it's in the numerator. So these are the 3 kind of takeaways to make sure you know. If you didn't write down the notes, make sure you write these down so you've got this. Makes your work a lot easier. All right, let's see here. Last thing, exit slip. Pause the video, look at these, decide if they're linear or non-linear. I'll go over the answers, and if you got them all right, you should be good to go for the work for the next few days. All right, so pause video, take a look. All right. So, number 1, if we look at the table, what'd you get? Linear or non-linear? 3, 6, 9, 12. It's going up by 3, so that's good. 12, 10, 8, 6, going down by 2, so that's good. So it is linear. The x's count by the same thing all the way through. The y's count by the same thing all the way through. So table A, number 1, linear. If we look at the graphs, what do you think? That curves, so nonlinear. Curves, nonlinear. Straight line, linear. And looking at the equation, find your x. There's x. The exponent's a 1, so that's good. But it's in the bottom of a fraction, so that means it is nonlinear. All right, I don't have to worry about those. So if you have questions, let me know. Make sure you have, make sure you've getting any of your missing work caught up, turned in. Check your Infinite Campus so you can see what your grades are. All right. Good job. I need to exit out of this.